All right, everybody. Whoa, there we are. Hey, hey. All right. Oh, where'd it go? You good? All right, everyone. Welcome back to the Dome. Hope everyone had a wonderful morning. My name is Evan McGee. I'm actually replacing Giovanni, who was supposed to be emceeing and speaking previously, but unfortunately couldn't make it this morning. But we're lucky to be here because now speaking is a fabulous Dr. Alex covering advanced WebRTC testing. Anything else you would like them to know before we get started? Nope. All right, let's kick it off.
All right, thank you, everyone. I like ConCon because that's a place where you actually both the voice over IP ecosystem and the WebRTC ecosystem coming together. We have a lot of things we should do together, but usually we don't for different historical reasons. So it's pretty nice to see new face and to see a different angle. Now, the downside of that is not a lot of people know about each other before or what happened in the other ecosystem. So I thought I would start here. I come under two flavors, right? So this year you have the top one, but sometime I have my incognito mode. So for the people that went to ComCom last year, that's how they remember me, right? Even a little bit, bigger beard. I was an academic by training, image and signal processing. I did a lot of work in WebRTC for the best part of last decade, especially in contribution to the standard committee and other things. Across different companies, both startup that I founded and Citrix. And now I founded Cosmo to be able to address some of the stuff that I thought were not really well addressed, both within the standard committee and by the big company for different reasons that I painfully learned at Citrix and other gigs. It's a team effort. There's 5 clones in my company, all with PhD, several language speaking and so on, and all sharing the same love for evolving the science, what is possible, and contributing back to our peers and people that are less capable than us. So we give back a lot. Not a lot of people know about all that we do. We publish most of our results, so we explain to other people how to replicate what we do. It's a little bit surprising for a company, but we think that's important, and that's also a way to protect IP. Some people have dual licensing to protect the code. If we want to prevent people from putting a patent against our own invention, even though we cannot afford to patent ourselves, you publish it, you get credibility in a scientific word, and you have prior art that prevent people to attack yourself with your own ID. We share the love with other people that share the love. If you're a WebRTC SFU developer, it's likely that we contributed code back to you. If you have put an open source stack in which we were using, it's likely that we were contributing back to you, and so on and so forth. A lot of things, when we cannot put them open source for security reasons, we put them out there for free. 5 years ago, we did an Internet Explorer plugin when Microsoft didn't want to support WebRTC to unlock the enterprise market for WebRTC, and we put it out there for free. So the financial interest is not exactly the reason why we did a startup. So in terms of publication, this is what we did in the past 2 years. We had to shorten the list a little bit to stay focused. We tried to work with everybody, so we have a lot of publication in collaboration with Jitsi, with Mitico, with Janus, with all the other guys. Not so much with the voice over IP, but that's just because we don't have them in our network. If there's people in the Asterisk, Camalio, whatever, name it, that want to work with it, we open to that. We haven't done that, but it's not that we don't want. We just don't know the people. Just wanted to put it out there. And we did a lot about testing and quality, which is mainly what we're going to speak about today. So last year, I presented Kite in general. So Kite has an history. WebRTC was the first API that was bringing peer-to-peer communication to the browsers. And my God, they didn't know how to deal with that, right? So none of the existing tools knew how to deal with that. Before, everything could be tested in one single browser at a time, separately. So everyone was in their own house testing his own stuff. Everything was good. And the tools were reflecting that. With WebRTC, if you wanted to start testing if only the connection, you needed to have 2 browsers. And then not all the browsers pair could be run on the same machine. So if you wanted to have Safari against Internet Explorer, you a little bit out of luck, right? So that was the situation. And so at the beginning, so credits to the Curento team to be the pioneer, to work a little bit on that. I wanted to put it out there. The very first problem is it doesn't connect. The second problem is when it doesn't connect, I don't know if it's transport, network transport, or encryption handshake. And then it's connecting, but the media is not flowing. So before you actually get an image or audio on screen or rendered or played, right, there are quite a few things that were happening. And since they were not testing that because they didn't have the tools, the first version of WebRTC in the browser were bad, like real bad. And they were aware of that. Once you're done with those basic problems, right, one browser at a time, then you have the divorced parent syndrome, right? So Apple didn't speak to Google because they forked Blink from WebKit. Microsoft didn't want to speak to anybody. Mozilla was, saving the freedom of the people and had to be opposed to everything that was perceived as attacking that. That was an interesting situation. So everybody had a one-to-one call working, but with his own browser. Chrome to Chrome, Firefox to Firefox, Apple to Apple. Well, not at that time. Let's keep Apple for later in the story. So now we had to have a Firefox to Chrome interoperability. So they were kind of forced to do that at one point because Microsoft say, well, WebRTC will never work. You cannot even make a call from Firefox to Google. So they got together for 1 month hack and they made a video and they make a public call between the two CTOs. But keeping it that way outside a specific focus was difficult. And it was about the tooling. So in Lisbon, at the technical plenary of W3C in 2016, I presented that. I said, guys, okay, nobody understands the gravity of the problem. If we only take the one-to-one call, and at that time people were already doing multi-party, GT was doing that, for example, this is what we want to support today. Android, iOS, Windows, Mac OS, Linux, with different flavor and revision of Chrome, Firefox, and so on and so forth. So if you count all the possible pairs, you end up with roughly 500. And that's a simplified case again, right? So that's what we wanted to test at that time. That's what we could test with the tool we had. We could not test when two browsers were not running on the same machine. So everything that was going across those operating systems was out. So what does that mean? With the technology stack we had, we could only test 23% of what we wanted. And actually, we were testing 5%. We were testing Chrome and Firefox on Debian only, which, as you all know, is very representative of the operating system of internet users out there. They're pretty useless. So at that time, I say the right design, if you don't want to get crazy to test all of that, is to have to abstract totally all the operating system, have a matrix that makes all the one-to-one pair, and just distribute the hell out of it, right? And that was the design behind Kite, presented to the standard committee for what I was hoping would be a collegial effort. So everybody agreed that that was the right design and we should do that, but nobody elected to do it at that time. Kite, so the K in Kite is karoshi, which means death by overwork in Japanese. Japanese is the only language where you have actually a word for death by overwork. And that really represented at that time what it would mean to test WebRTC and all the corner cases with all the stuff. So that was done, that was presented last year. It's a little bit improved right now, but the advantage of Kite is you can have desktop or mobile, you can have browser or native app, and you can test a little bit of everything you want, right? So once you get that, you can start doing all the pairs and check that the media goes through. So native app, Electron. Electron is easy. It's Chrome in disguise. There is a WebDriver. Native app is a little bit more difficult. The core of Kite, everything that I presented so far, is open source. Is provided for everybody. You have sample tests with all the tests you need to start testing against all the open source WebRTC, SFU, GT, Janus, Currento, MediaSoup, Midus, whatever you want, right? It's already there, and you have a few tutorials to help you start writing your first test, either in Java or in JavaScript. Choose your poison, right? So enjoy. Test reports. So we decorrelate running the test from the report of the test. So the test runner actually only outputs JSON file that you can, parse if you want, but most of the people don't want to parse. So we provide a few default dashboard that allow you to represent nicely the different tests and all the logs. So that consolidates all the logs from all the different instances nicely. We have two of them, one more CO-oriented with pies and percentage, and one which is more engineer-oriented like that, when you can go one by one, all of the tests, all of the logs, and that's when you really want to debug if something goes wrong. People have been using it, so I wanted to mention one open source project that was done for free on top of that. For example, called stat.io. Varun, the CEO, decided to use that to test the compliance of the statistics across the browser. He was the editor of the specification about the stats, and he was getting upset that the browser would not implement it. So in order to rub it a little bit in the face, nothing better than data. So he used Kite to generate the data, and then they made a web app just to present the data in a much better way that our engineer-oriented stuff was. That's an old screenshot. I'm not sure it has really improved, even though the recent Chrome release claimed to be a little bit more stat compliant, but okay, they're getting there. So just to give you an example, I don't know how long it took you guys to do that, but that was not a big effort. Now like 2 weeks, something like that, on top of the open source Kite, right? So that's the kind of cool stuff you want to do. And then we say, okay, interop is nice, but now I have that tool that allows me to launch as many instances I want and dictate and automate them and instrument them. Let's go to the next question, which is load testing, right? And load testing is a little bit the same, but the focus is not on testing the client side anymore, so you don't have like 10,000 different client side, different version of browser and so on, but to put some load on the media server or the signaling server. So in that case, we usually choose only one client, but then we run 200,000 of them, and we have a scenario that decide the ramp up, right? Do I want those 200,000 people to connect exactly at the same time to the server? I might not want that. That might not be realistic, or I might just want that to see if I crash or not, right? Anyway, so now you have a script that allows to do that. Here again, we work with everybody in the community around, I think, 1 full year to make this available for all the open source SFUs so people can actually compare ourselves. We did the first run ourselves. The first 6 months, we communicated the result to all the team, and we gave the choice to the team. We gave them 6 months to correct the bug or address and so on, or to elect out of the publication before we actually published, to be fair, because the goal was to help everybody get better and to show what is possible with the tool, and not to trap anybody and be unlucky that we tested exactly one version that was bad, or we made a mistake into installing the SFU because we don't really know. So we wanted to involve all the team to make sure the installation was done correctly, it was the right version, it was the best they could do by themselves. It was nice. So Lorenzo can give feedback. He was part of it if you want. Is Boris here? Or you can catch Boris from GT, he was also part of the thing. We end up with something like this. This is one of the draws. See, this is the round trip time as the load augments, right? So you get stressed, you answer slower, but how much slower do you answer with respect to the load, right? So Currento was going into 100 seconds very, very quickly. The team say, well, we know we don't have time, we just got bought by Twilio and so on. Okay, that was not very representative. They addressed it since, then, you know, things are back to normal for them, all good. GT was crashing at 247, but that was a non-bug that has been addressed yet. And for them, it was not a load balancing system they had in place and they were proposing to people, was focusing on up to 100 people per instance. And they were crashing at 247, so for them it was like not a problem, right? So, and of course, I don't remember if it was MediaSoup or Janus that eventually won the load, so that's another drawing. So that was nice. It led a lot of other companies that had commercial SFU to come to us to actually replicate the study for them and help them identify the bottleneck and improve. So we had a nice keynote yesterday about how do you make money from open source. That's one of the way. You put the engine, you put everything open source, right? But then you show a certain expertise and people come to you punctually to replicate it. Because sometimes they need also to have a confirmation from a third party. We do some due diligence in case of acquisition and things like that, right? So that's one of the way of monetizing an open source project. And when we went there, we said, okay, this goes in real time, so it would be nice to have real-time probes as well, right? What am I measuring? So of course we had GetStats, and everybody can hijack GetStats. We have a little module for the native app that actually implement GetStat if you don't have it in your native app. And GetStat is real time, but the media assessment at that time was not real time. Most of the people were using SSIM or VMAF, which requires a reference frame. So if you have real-time media and not pre-recorded media, you cannot do it, or you cannot carry the reference frame at the same time you carry the frame to be able to measure on the spot. So we developed something called Narval that would give you the same score that SSIM or VMAF would give you, but without requiring the reference frame and with a better speed. We published the paper. Everything is explained. People can replicate it and recode it if they want from the paper, and if they don't have time or capacity, they can come to us and ask for a package. So once you solve all the connection and interoperability problem, okay, it connects, I have audio and I have video, you go from binary word, it works or it doesn't work, to 50 shades of gray, or at least 5, right, which is what is the quality of my call. At that stage, it's becoming difficult, but unfortunately, this is where the ecosystem is today. More or less, everybody has figured out how to connect and how to get the media flowing in different configuration, the use case, but the quality is not always there. And some people say, you know, the question that comes back all the time, how does Zoom do that? How do I compare to Zoom? And the problem is not in the lab where the bandwidth is great all the time and everything is cool. The problem is that when you go over the public internet, the bandwidth is going to fluctuate. There might be different jitter, no, so the network, the quantity, bandwidth, and the quality, jitter, packet loss, and delay can vary a lot. So there are different mechanisms in place to address that, but they have different flavors, right? So you need bandwidth estimation, you need congestion control, then you go into Simulcast, where you need to be able to change layers. SVC has also a layer changing logic, and all of those have different ways to be implemented. So the congestion control, for example, is ridiculous. So right now there is at least 5 congestion control implemented in different browsers across, with not really a common one. I'm not going to go into there, but one of the questions people say, the people that have just first level of expertise is, how does my solution behave if the packet loss go to 10%? The second question is, how does it compare with the other people? And the third question, the third level, more complicated, is, would it be better if I was using this? Would it be better if I change the congestion control? Is it getting better if I go from sender side to receiving side bandwidth estimation? Is it better if I use VP9 SVC instead of VP8 Simulcast, right? No, not in terms of compression, of course, but in terms of adaptation to the network. What does that mean? That means if the bandwidth drops quickly, you know, your son is connecting to the internet and streaming during your call, how fast can you adapt? Or what's the quality of the adaptation? You know, that's really user experience. So it's all about this timing. In other words, how do I replicate this experiment from JIT-C automatically for any infrastructure or SFU? So Emil was quoted one day saying, JIT-C is much better than Zoom. People got upset at that, so he made a blog post where he actually took a video of himself showing that if you change manually the bandwidth using the bandwidth limiter on the Mac, and you time how long it takes for the system to notice the bandwidth has changed, 1, to adapt to it, 2, and how good was the adaptation, 3, and then for all those 3 metrics, JIT-C was much better than Zoom, right? No, that's fantastic, but it's manual. You need to embed a QR in the frame because VMAF of SSIM need to have frame-to-frame comparison, so you need to match the frame before you actually make the measurement of the quality. You need to have a manual network limiter, so that software is on Mac only, you don't have the same on Windows and so on. So I want to do that, I want to do it automatically, I want to do it on any operating system, even if it's mobile. Right? That's what the Kite Network Instrumentation Module is for. So network instrumentation is very simple. You can simulate firewall and NAT in terms of port and protocol blocking and things like that. You can change the network conditioning, so bandwidth, packet loss, latency, and jitter, but for each of the entity separately. So you could have a different network profile for mobile because they're on 3G, then from the server, then from the turn server, so it's really flexible. That allows you to test things like in streaming, for example, the first thing we tested for Millicast was the noisy neighbor. You check that one guy on a bad network is not actually contaminating the entire system and causing the other people to experience a bad user experience, to have a lower quality bandwidth just because one of the viewer is on a bad network, right? So the complicated part, of course, was to make it work across. You have different solutions that do that, but that Linux only, because they're server-oriented, they're mobile only, they're Mac only, and so on. So the difficult work there was to do something that would work across all the possible operating system and configuration we have, that could work on premises and on the cloud, and that could have a single configuration file, right? So you define, so you can see on the bottom right hand, you have a configuration for each of the network profile you want, where you put the network. You can make it vary across time, start with 2 megabytes, then go to the next profile, then come back up, and so on and so forth. So that's pretty much everything you could think about. So we made a demo. So I don't remember which one is that. So we did it with all the 5 open source SFU. Don't look at the result. It's not tuned. We have not exchanged with the team, so we don't think it's representative. So it's just an illustration. So look more at the process, what we achieve, than done. So what do you see? You see 2 computers with remote desktop connection, where we're going to automatically launch browser, connect to the URL and instrument. The shell over there is actually the Kite engine itself, right? That is controlling those 2. And on the top right hand, you have the dashboard, which in real time is going to collect from all those machines all kind of data, right? So you can actually do the inspection in real time. So that looks like Janus. It looks like Janus. So it's gonna crash at one point, but here again, this is not Janus. This is actually the browser crashing, and not even crashing. So that's the interesting part. So we have a video that is using 1,700 kilobits, right? And we start with 2 megabit bandwidth, and then we're going to lower it down to 800 or 500 and see what happened, right? So we're gonna check. We're checking the bit rate, the frame rate, and things like that. We didn't put QR because we're low tech. GT is much better than us, so we just put the number for the frame for people to visually see. You see there is already a delay or a drift between the sender and the receiver on the video there. So at one point, and I might actually accelerate because that's a long one. Let's make it crash fast. Right, so we changed the profile, we reduced the bandwidth, we have made a video again with GT and Midus and so on, we have made a video with the packet loss. We're going to put everything online, but right now I'm just presenting one video for the concept, right? You can come back later online. I will provide the link on the mailing list for if you want to see the other video. So that's an interesting one. It crashes and then it comes back, right? So the connection, it's actually disconnect, the server disconnects, and then in one case it reconnects, and in one case it does not. But what's interesting is it's still receiving the media. So you see the 550 kilobyte per second on top? I mean, it's streaming, but either the decoder or the renderer is dead. So that's a bug in the browser. That's not a bug in the media server. But nonetheless, it's going to impact the customer you service. So that kind of thing then, we use it, we open bugs into the browser vendors. We can automate it on all the different browsers. We usually do it against Canary as well, because the Google team only fixed the bug in Canary. So if you wait for the stable version of the browser and you find a bug, they tell you, well, you have to wait 3 times 6 weeks before the fix reach out stable, right? Unless it's a security bug. So we help people setting up an infrastructure so not only they can detect the bug early, but they can detect the bug in a way that the browser vendors are going to act on it before it reaches the stable browser and impact the customers. So that's pretty much it. So we go back to normal later on, so you can see the curve going up. This one never comes back. So the bit stream comes back to 1,700 kilobits per second, but the renderer or the decoder are dead. They never come back. So in principle, that's what it does. The only thing we had to do was to write a JSON configuration file, which the network profile, the browser profile we wanted. So here it's Chrome 75 on Windows, I think, right? So browser revision, operating system revision, and you push the button, right? So that's the demo. All right. Some people ask us, how do you make money, right? And the keynote was going there as well. You know, how do you make money for that kind of thing? Well, we make money pretty much like any other kind of open source product. Is expertise. So people come to us for professional services or consulting and so on. And just like Nginx or Red Hat or other people, you have a first product that is open source and for everybody to use and so on. And then you have a commercial one, which can save you time or is easier to use. And then the balance is, do you have more time than money? So if you have more time and expertise than money, you're a PhD student, congratulations. You're going to go for the open source one, and you're going to have a lot of fun. You're going to write a lot of paper. You're going to enhance the science. Everybody is happy, right? If you want to evaluate, then the open source is there. Take it, use it, and so on. Now, if you don't have time for that shit, right? Or you don't have a team that understand the 20,000 protocols you need to know to be able to debug that, then we package it, right? So we have a product called the Grid Manager. You still need to write the test script, okay? The script don't write themselves, but you can set up the Selenium grid with a click interface. You have full control about the grid configuration, what kind of OS, what kind of native app, web app, and so on you have, again, with a clickable interface. You upload your test file, and then you push the button and you decide how you run them, right? And then we have different kind of automated dashboard for reporting. Again, one CEO type, which is more qualitative, and one that is more quantitative for people that want to debug and use it as an aggregation. Okay, that call didn't work, but is it coming from the turn server? Is it coming from my client? Is it coming from my media server? Okay, now I have all the points. I can do an end-to-end traceability of my data and get there, right? So that's the kind of thing we do. I don't know until when we had. If we have more time, I have more video. Dan, what's the session until? 5 more minutes? 5 minutes? All right. Yeah, let's open the floor to questions. You have a...
Mic is... This one. Oh, there it is. Okay. Yes, so there's plenty of time here. Thank you, Alex. Thank you very much. Are there any questions for anybody? Yep.
Does the Kite Grid Manager allow you to run on your own AWS
Yes.
cloud? Awesome. Is it just AWS or other services
so
as well?
anything you want. But right now we support, we have customer using it on Amazon. We just added Azure and Google Compute Engine support. We haven't had any customer using it right now, so maybe it needs a little bit of love. The way we do it is to reduce the price of the load testing. We didn't want to do a full hosted operation. You would pay too much. So we rent you one machine, right? That is the command and control. You input your, and we have prepared the virtual machine image that contain all the Selenium, everything you need to spin up instances, and we did the benchmark to make sure that you do something that is not biased, right, by trying to feed too much browser in a single instance. So you put your Amazon Web Services credential in it, and then it's spawning the machine for you and so on and so forth. So you only pay for that single machine, and then the rest of the loads, really, the one doing the job. If you, on streaming, we reach 250,000 machines for load, yes, for load testing. You know, HBO, Game of Thrones, it's 48 million people. So you want to speak with cable TV on streaming, they say, come back when you can show me you handle 2 million, right? We can do that. No, I think it's 4. I would have to check, but it's definitely not 1-to-1, right? Now, that being said, for the load testing, we're using Chrome or Firefox because of that. Chrome and Firefox can have multiple instances of themselves on the same machine and be automated, but Edge and Safari only allow one process per machine. So if you want to do a Safari to Safari test, for example, you need to have 2 separate Mac OS. And so in the Kite, you actually have a dispatcher which handle those browser specificity and WebSocket specificity to make sure you have the maximum load. So if you want 10 Chrome, it's going to be packed into single machine, and then everything that is a mono process is going to be a separate queue for the load balancing, and so we hide that to you. Yes, Oscar.
Which is more or less the ratio between number of browsers core, let's say number of cores per browser that you allocate there.
You mean as in CPU cores?
Yeah, let's say CPU cores per browser, let's say.
I don't have that number. Okay. I can find it if you want it, but that entire team is under the hand of a very gifted guy. Thanks God, I don't have to micromanage him. He's doing a fantastic job. I know he has the number. If you want it, send me an email. I'll give it to you, but I don't have it from the top of my head.
Thanks.
Are you planning to do, of course you are very focused on video, are you planning to do something more related to just calls and also maybe from a VoIP perspective interconnecting with SIP, with a project like JS SIP?
We do it already, so we have some client that use, so Kite is not specific to WebRTC at all, and it's not specific to video, we just have more probe dedicated to that, but Kite is basically taking 2 apps and running them in parallel, right? So you can use it to test chat, just simple chat, right? You can do audio and video and so on. So the audio problem is pretty much solved. You have things like Polka for quality. You have a lot of things that have been out there. For video, especially real-time, there were a lot of gaps. So that's why we're doing research there. It's not so much because we have more customers for it. It's because we cannot deliver a solution at the same level of quality for video that exists today for audio. So everybody that is interested in that kind of thing and that is in the Montreal area toward the end of the month, we have a free, food is free too, hackathon just the weekend before the IETF, so the 20 and the 21. It's open to everybody, so everybody that wants to meet the WebRTC team from the browser vendors, please do not yell at them. The SFU vendors, people doing the testing and so on. We have a special table, you know, we want as many people as possible to come and give feedback to us. You also have usually 2 W3C representatives. So Dominique, who represents W3C in the Get User Media and WebRTC working group, is here on the table because he wants to hear more feedback than just the browser vendors that are on the table usually. So if you have a specific need or specific feedback and so on, or just want to put a face and have contact and so on, join us. The more the merrier.
Awesome. Anyone else? Cool. Well, thank you so much, Alex. We appreciate it. Great talk. So now about 5 minutes.